Hello, welcome back. Today we're going to do should be review for you radicals. But before we get that started, you're getting one of these books today, and this is where I want you to keep your notes. You're going to turn this in at the end of the unit while you're taking your test so that I can grade it. So this will be our similarity unit. And of course you're going to want to put your name, you change this name, period, row number on there. Okay, so on the back of the front cover, this is going to be your table of contents. So yesterday we did the proportions, so that's page 1, and you can just, once you get your paper back, fold it in half, tape it in here, and like we've done in the notebooks, and that will be your notes for the proportions. And then page 2 today is going to be our radical operations. All right, so that's where we're going to start today on page 2. And so I would write that at the top. Page 2 will be the back of the next page. You notice this is just a short little booklet, but there'll be enough for you guys to get your notes in, hopefully, for this unit. So radical operations, and I actually have given you your foldable, so you should have 3 strips of paper, and this is how I want you to line them up. So the first one has, you want to put the divide up, the multiply would be down, so it'll be divide up. So you're going to match up these bottom 3 things: divide, rationalize the denominator, and add and subtract. So you just line those up so that they're visible. You want to kind of squish them down as far as you can without covering up the letters, okay? And then you're just going to fold over the top like that, and you'll have your radical little booklet, okay? And then when we're done, you can paste that into here. What I want you to do is just line it up on that pink line to the side, okay? So that's what it'll look like, but we're going to do some notes first. Now, when you use radicals, the thing you want to look for is when they ask you to keep something either in simplified radical form. This is what you would want to do it this way. So you're going to write this over to the side. It's when you're keeping in simplified radical form, which may be asked for. Or if they ask for the exact values. So exact values are not decimals, okay? They're simplified radicals, and they don't want you to go on a calculator and just punch the numbers in, okay? So those are the 2 kind of things to look for. If you're wanting to use this radical stuff, then those are probably in the instructions, unless it's already a radical problem. All right, so when we open up our radical thing, the first thing that you see might be familiar to you, okay? These are our perfect squares. Remember, we were doing our perfect square quizzes. This was to help you get ready for this. So these are your perfect squares up to 12 squares, okay? So you have 1, you have 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, and so on. Finish that out so you would know what those numbers are, all right? And so if we look at our first example, square root of 32, what you're looking for, there's 2 ways to do it. We'll do it the way in here, and then over here I'll show you another way. But basically what you're looking for is some number that multiplied together, one of those would be a perfect square. So if you look up here, 32 is 16 times 2, and the square root of 16 is 4, and 2 is not a perfect square, so it just stays there, okay? That's one example. Another one is this one, where we have 75. Well, 75 is 25 times 3. So the square root of 25, because it's a perfect square, is 5. And then the 3 it doesn't have a partner. It's not a perfect square, so it's still a radical. And when you do your variable, it's the same kind of thing. X squared, the square root of that is just going to be x. And then your x would not have a perfect square root, so it would stay inside. So this is what a simplified radical form looks like. Now, sometimes you can't remember or you can't figure out what the perfect square is. So I'm going to show you another way. I'll use these same examples so you can see the difference. So the square root of 32, okay, what we're going to do is we're going to use what we call upside down division. So we're looking for basically the prime factors, or actually the factor chart. You might have done it as a tree for 32. So you go with the smallest prime factor, which is always 2 for an even number, and 2 goes into 32 16 times. Now, from here, if you know the square root of 16 is 4, you're done, because you're still looking for the square root of all this, okay? If you don't recognize that, then you go again. 2 goes into 16 8 times. 2 goes into 8 4 times. 2 goes in 4 2 times. Now, once you're done with the prime number down here at the bottom, you can't take anything else in there. Now, the thing about a square root is you're looking for a number that you need 2 of them to come outside of the square root sign. Okay? So this is basically here the square root of 4, the square root of 4. And the square root of 4 is 2. So this 2 comes out, this 2 comes out. This is still the square root of 2. Okay? Because he does, I like to say, he doesn't have a partner. He can't come out of the radical sign. So your answer here is 4 square root 2. Now, more writing than this, yes. But if you don't know when you have a perfect square, this is your option. Okay? It's the same thing with the variable ones. If you have the square root of 75, x to the third, oops, forgot my 7, okay? You're going to do the same thing. You've got 75. Now 2 doesn't go in there, but 3 does. And that's 25. 3 doesn't go into 25, but 5 does. And then you've got 5. And then you've got x times x times x. That's my x to the third, okay? So we always look for pairs. The 5 comes outside. The 3 stays in. And we've got a pair of x squared, so those can be out there, and only it's just x to the 1, because it takes 2 to make 1, and 1's left inside. So our answer to this would be 5x square root 3x. All right, and if you ever want to check that, you square the outsides. 5 times 5 is 25, times 3 would be 75. X times x would be x squared, times x would be x to the third. All right, so that's a very quick lesson on simplifying radicals. You might want to try some practice. You will get some practice, and you might want to walk them through using the video as you're doing that. Now, as we look at our foldable, the product property, that's when we're multiplying radicals, okay? So, when you're multiplying radicals, you're factoring the radicand into the product of a perfect square and another number. Take the square root of the perfect square and leave the other number under the radicand. This is the radicand sign, okay? In case you didn't know what that was. All right, so for example, we are going to do the first one, square root of 9 times the square root of 9. So you can do it a couple of ways. Number 1, you can recognize that 9 times 9, that's 2 9s, okay? Just like we needed 2 2's to come out and make 1, 2 9's makes 1 outside the square root sign, okay? Or you can say this equals the square root of 81, okay? And 81 is a perfect square, and so that equals 9. And you can do it either way. Now, for this next one, these can go together because they have the same square root sign. If it was a different base to this root to this square root sign, it would be different. But this is 3 times 2 times g to the third. Okay? So the 2 can't change. It's going to stay there. But we have, if you look at this, we have 1, 2, 3, 4 G's, okay? 3 here, 1 here. So that's 2 pairs. So we would have 3G squared, okay? Because 2 of those make 1 outside, and then left with the square root of 2 inside, okay? When I say outside and inside, I mean outside and inside the radical sign, all right? If I can move this in just a little bit closer. Okay, and so we're going to do the same thing here. 2 stays out. We've got a 5 inside. We've got m squared times m, and then we've got n squared, okay? So m squared would come out because there's 2 of them. It already tells you that. The n comes out because there's 2 of those, okay? What are you left with here? Just 5m. And that would be your answer. So this is your answer to this one. This is the answer to this one and to this one. All right? So those are 3 different examples for when you're multiplying. So now let's look to the quotient property, which means to divide. So when you're doing this, just like we could put them all together and separate them when we do the multiplication, we can do the same thing with the square root of a over the square root of b. So what you're going to want to do is rewrite the fraction as square roots of the numerator and the denominator. Now what I will tell you is if you can simplify, you should do that first, okay? So before you split this up, you might want to make sure that it doesn't simplify. So for example, if it was 16 over 4, well, 16 over 4 is just 4. It's much easier to find square root of 4 than having to do the square root of 16 over the square root of 4. And you're still going to get the same answer, okay? So let's look at a couple of examples here. This one you can write as square root of 5 over square root of 49, okay? Square root of 5 is just going to stay. Square root of 49, 49 is perfect square. That would be 7. All right, and that's how you would work that out. This one, square root of 11 over square root of d to the 4th. Square root of 11, 11 a prime number, can't change it, but d to the 4th is d squared times d squared, right? So that makes that just, there's 2 of those, just d squared. That's the square root, okay? And so dividing, that's how you would do that, separate them out. Now, sometimes when you do that, your division ends up with a radical in the denominator. So you have to look at the definition of a simplified radical. So simplified radical does not have a radical in the denominator. So we have to have a way of getting the radical out of the denominator. And what we do is to simplify it, I need a different color really quick. So to simplify, we multiply the fraction by 1 to create a perfect square in the denominator, okay? Because once we have a perfect square in the denominator, we can take the square root, all right? Perfect square radicand in the denominator. All right? We'll try that root. For example, if our radicand is square root of 7, we're going to multiply it by square root of 7 over square root of 7. And this is our 1. Okay? So when you do that, let's say that was just 1, it would be square root of 7 over square root of 7 times square root of 7 is just 7. Okay? And that's how it's called rationalization. See at the bottom it says rationalizing the denominator. Whoops, sorry. There we go. Rationalizing the denominator. So here's an example. All right. So you've got 7 over square root of 6. They're going to multiply it by the 1. I like to draw the little 1. Here we go. 1, which is square root of 6 over square root of 6. So when you get that, you get the square root of 36, which is 6, and then you get the 7 times square root of 6 in the numerator. This is considered a simplified radical. And that's all you have to do. You would stop right there, okay? And then on the bottom, another example with variables, you would do the same thing. 5a times 5a gives us 25a squared, but since there's 2 of them, that's 5a in the denominator without a radical. And then 3 times 5, it's the square root of 3 times square root of 5 is 15a, and you can't simplify that anymore, so it stays just like that. All right? If you have questions about that, please let me know. Okay, so last one, adding and subtracting. So let's look up here at the notes really quick. Like radicals can be combined by adding or subtracting. Think like terms. For example, let's not use a 4x plus 3 minus 5x. We would do those. We could put those together, and that would be negative x plus 3. Okay? It's the same thing with the radical. It has to be exactly the same. The square root of 3 plus the square root of 3 is 2 square root of 3. Okay? The square root of 3 is like the x. So when you add and subtract the coefficient, and you keep the radical the same. Okay? And then sometimes you have to simplify before you can add or subtract. Maybe they don't already look alike, so you have to see if they can be simplified so you can tell if you have a like term. So let's take a look at an example down here. In this case, we know the 14s are like terms. So we've got this one and this one. And so 7 minus 4 gives us our 3. So 3 square root of 14 plus 21, that would be your answer. Now, in this one, those are not like terms. But 28 is 4 times 7. So the square root of 4 is 2. So what we really have is 5 square root of 7 plus 2 square root of 7, which gives us 7 square root of 7. Okay? So those are all of the different radicals. What you'll want to do is get this foldable in here. And you'll want to glue it right in there next to your paper with our extra notes here. And then those would go in your, those would be pasted into your notebook so you can practice. The worksheet that you have for today for this work is just a couple of each of the different kinds of problems. So there's about 20 of them because there's 20 different ones. They have numbers and they have variables. There's 10 different ones. So they have number ones and variable ones, and those will be due on Thursday. So I'm going to give you an extra day because there's several of them. You'll have time in class, but you also need to do some of your test corrections and stuff. So the homework is due, I'll write it here, on Thursday. So that would be today is 14th, the 16th. Okay? Let's see. Well, let's make it Friday. Sorry, I'm a day ahead of you. So we do the 17th. Help you out there. Okay? So that should be everything. Oh, on your sheet with the vocab on it, I don't think there's radical on there, but I'm going to put one on there, one of the empty boxes, and so that would be a place where you can link to get back to this video. And you on there should put this. This is what should be on there so that you know about radicals. Keep them in simple radical form or exact values. That's the important thing to watch for. If you don't know when to keep it as radical when you use a calculator, that could prove to lose you some points. Okay? Thanks for listening, and I'll see you in class.